Imagine standing in a muddy medieval village sometime around the 12th century. No electricity, no engines, no steel cranes towering above the skyline. And yet, rising in the distance is a cathedral taller than anything your ancestors had ever seen. Stone weighing several tons climbs toward the heavens. Entire mountains are carved apart by hand. Thousands of workers spend decades, sometimes centuries, building structures designed to outlive kingdoms, and somehow, many of them still stand today. So how did medieval builders construct castles, cathedrals, bridges, and entire cities without modern technology? The answer is one of the greatest engineering stories in human history. After the collapse of the fall of the Western Roman Empire, Europe entered a period of political fragmentation, causing Roman roads, aqueducts, and many advanced engineering systems to deteriorate. However, medieval society was far from stagnant. Over time, Europe developed a new construction culture driven by the needs of feudal lords, kings, and the church, who required castles, fortifications, and grand cathedrals as symbols of power and faith. By the 11th and 12th centuries, a major building boom transformed Europe, with massive churches, stone castles, and fortified towns rising across the continent. These projects relied entirely on skilled human labor: quarrymen, masons, carpenters, blacksmiths, and countless workers shaping every beam and stone by hand. Despite limited technology, medieval builders achieved remarkable engineering feats that still impress historians and engineers today. Medieval construction began in quarries, where workers used iron chisels, hammers, and water-expanded wooden wedges to split massive stone blocks from rock faces. Transporting these stones was often even more difficult, requiring oxen, horses, barges, and large teams of laborers, as cathedrals and castles demanded enormous quantities of material. Construction sites became complex industrial networks supported by carpenters, blacksmiths, lime burners, and quarry workers, all directed by the master mason, a skilled figure who combined the roles of architect, engineer, and project manager. Without modern blueprints, knowledge was passed through apprenticeship and practical experience. By the 11th century, Europe shifted from vulnerable wooden fortifications to massive stone castles designed for warfare. Thick walls, towering keeps, concentric defenses, and carefully planned gatehouses turned castles into highly effective military structures. Features such as clockwise spiral staircases, layered walls filled with rubble, and elevated towers gave defenders major tactical advantages. Building these enormous stone fortresses required solving difficult engineering problems involving weight distribution, foundations, and structural stability, and many techniques improved through trial, failure, and experience. While castles symbolized defense and warfare, medieval cathedrals represented faith and pushed construction technology to new heights. Early Romanesque churches relied on thick walls and rounded arches, but these designs limited how tall buildings could rise. The development of the pointed arch, ribbed vault, and flying buttress revolutionized architecture by distributing weight more efficiently and redirecting pressure away from walls. This allowed Gothic cathedrals to become taller, lighter, and filled with enormous stained glass windows that created awe-inspiring interiors for worshipers. Building these cathedrals required extraordinary coordination, often taking more than a century to complete, with generations of workers contributing to projects funded by entire communities as symbols of religious devotion, wealth, and civic pride. Despite lacking modern machinery, medieval builders used advanced mechanical tools such as treadwheel cranes, pulleys, levers, and counterweights to lift massive stones and construct towering structures. Large scaffolding systems surrounded building sites, while skilled carpenters designed complex wooden frameworks and roof trusses using timber harvested from vast forests. Blacksmiths continuously supplied essential iron tools, including chisels, nails, hinges, and saws. Together, masons, carpenters, blacksmiths, and laborers formed highly organized construction networks that combined practical engineering knowledge with remarkable craftsmanship. Medieval engineering extended far beyond castles and cathedrals, as growing towns required bridges, roads, walls, and urban infrastructure to support expanding trade networks. Builders constructed durable stone bridges using deep foundations, cofferdams, and diverted rivers, while fortified city walls, guarded gates, and watchtowers protected urban centers and controlled commerce. Although medieval cities often struggled with overcrowding, poor sanitation, and devastating fires, they became important hubs of economic and social transformation. Behind these achievements, however, construction work remained extremely dangerous. Laborers faced constant risks from collapsing scaffolding, fallen stone, and exhausting physical conditions, with little medical care or personal recognition. Yet many workers viewed their labor as a spiritual duty, especially when building cathedrals that symbolized the faith, ambition, and collective identity of entire communities. The legacy of medieval construction continues to shape the modern world. Techniques developed during the Middle Ages, including vaulting, load distribution, structural reinforcement, and crane mechanics, influenced Renaissance and later industrial engineering. Large building projects also stimulated trade, created specialized professions, accelerated urban growth, and concentrated political power within cities. Gothic cathedrals transformed architecture by using height, light, and scale to create emotional experiences that inspired awe and devotion. Many medieval structures still stand after centuries of war and weather, demonstrating the remarkable durability of their design. Despite lacking modern technology, medieval builders achieved extraordinary feats through patience, coordination, craftsmanship, and long-term vision, creating monuments intended to outlast generations, and many ultimately did.